intermediate value theorem. So the intermediate value theorem, if a function f is continuous on the closed interval a, b, and f of a is not equal to f of b, and k is any number between f of a and f of b, then there is at least one number c in a, b, such that f of c equals k. Now what this means is, let me show you graphically. You have this function. This is continuous. It's just like one curvy line. And we have the interval from a to b. This is f of a, and this is f of b. Now since this function here is continuous, and you have this interval from a to b, and you have f of a here at this y level, and f of b here at this y level, k is some number. It's between f of a and f of b. So because of the intermediate value theorem, now they have this information, that means there is at least one value c. See here we have three values. There's at least one value c at which f of c is equal to k. So we have 3 points right here. This function down here, this is not continuous. You see there's a jump discontinuity at this point here. And so we have our a and our b in this interval. And we have f of a and f of b, and k is between those. But because the function is not continuous, then it is not guaranteed that there is a value c at which f of c equals k. However, that doesn't mean that there is no value c that equals k. It just means it's not guaranteed. Let's say we have k right over here. Well, there is a value c, but since between a and b, but since the function is not continuous, it's not, you don't know, it's not guaranteed that there is a value c where f of c equals k. Let me show you some examples. So your height is a continuous function, h of t. Right? It's continuous because it changes slowly over time. You don't grow right away, you grow over time, right? So it's a continuous function. What was your height when you were 3 years old? What is your height today? Explain why there must be a time, c, when you were exactly 4 feet tall. And going back, we have all this a, b, c, k. Let me show you what those mean. First, you have your continuous function, h of t. Write down that it's continuous. Being continuous is really important for the intermediate value theorem because it has to be continuous for it to work. Now your a and b are the ends of your interval. So here in this question, it asks you from 3 years old to today. Let's say you're 16 years old. So this here is your a, and this is your b. Now next, you're going to find your f of a and your f of b. So your h of a, which is your h of 3, then your h of b, which is h of 16, right? And then, so the height when you're 3 years old, let's say you were 2 feet, right? 2 feet tall. And at 16 years old, now let's say you're 6 feet tall, right? Say if age of 3 is 2, and age of 16 is 6. Your K is going to be this final value here. This time C is what you're trying to find, when you're exactly 4 feet tall. So you have to use this information to prove that there is a time C when you were 4 feet tall, right? So K, which is 4, it's between 2 and 6. So you write that down. These are 2 conditions for intermediate value theorem. You have to have a continuous function, and K has to be in between this interval. And since these 2 conditions are fulfilled, that means that there must be a time C when you were 4 feet tall. Now think about it, it's logical. You don't just grow from 2 feet to 6 feet directly, you grow over time, really slowly. And there is an age between 3 and 16 where you're exactly 4 feet tall, since your height is continuous. And that's basically what the intermediate value theorem is. I'll use some actual functions. If f equals 2x cubed minus 3 on the interval from 1 to 2, is there a value C such that f of C equals 0? So here's your C again. This is your A, this is your B, your interval, and this here is your K. So first, is f continuous on your interval A, B? So our interval that gives us is 1, 2. And 2x cubed minus 3, if your graph looks something like this, this is a basic polynomial function. And polynomial functions are going to always be continuous. Now if you have x squared, that's always continuous. If you have x cubed, that's always continuous. These polynomial functions, they're continuous. That's how you know that this function is continuous on the interval from 1 to 2. Now you have, is k equals 0, we have our k value here, a number between f of 1 and f of 2, your a and b values. The first step here, now you have to calculate what f of 1 and f of 2 are. So here's f of 1, that's 2 times 1 cubed minus 3, it's 2 minus 3, which is negative 1. And f of 2 is 2 times 2 cubed minus 3. 2 cubed is 8 times 2 is 16. Minus 3 is 13. And yes, k, which is 0, is between negative 1 and 13. It's between your f of 1 and your f of 2. So you have condition number 1, that's continuous. Condition number 2, that k is between your f of a and your f of b. Now since these 2 conditions are fulfilled, that there is a value c where f of c is 0. So the answer is yes. This is a way you could write it. Yes, since f is continuous on 1, 2, and the value k equals 0 is a number between f of 1 and f of 2. Intermediate value theorem guarantees at least one value c on the interval 1, 2, such that f of c equals 0. Now we have a table, and a particle moves along with a continuous velocity, v of t, where v is the velocity at time t. Selected values of v are given in the table. Another particle moves such that its velocity is given by m of t equals v of t plus t. Explain why there must be a value c for 10 is less than c is less than 15, such that m of c equals 20. Now again, you have your interval here, your a and your b. The c is what you're trying to prove exists, and this 20 is going to be your k. So first, what does this here, this m of t mean? Let's figure it out. First, note that v of t is continuous, and all you're doing is adding a number t to v of t. So m of t is also continuous. It's a continuous function, because the problem specifically states that. So that's condition number 1. Now we need to find your f of a, in this case m of a, and your m of b. So let's do that real quick. M of a, which is 10, equals v of 10 plus 10. In the table, if you look at 10, the value for v of 10 is 9.5. So m of 10 is 19.5. Now let's calculate m of 15. That's your b. That's v of 15 plus 15. If you look at 15 in the table, you have 7. That's 7 plus 15, which is 22. Now note that 20 is between 19.5 and 22. So your k is between m of 10 and m of 15. That's your second condition. And now that you've written these two conditions down, right, yes, there is a value c between 10 and 15 such that m of c equals 20. That's how I solve that kind of problem. Here's the last one. A particle moves along a continuous function x of t, where x is the position at time t, such that x of 1 is 3 and x of 5 equals negative 2. So it gives us these values. Explain why there must be a value r between 1 and 5 such that x of r equals 0. Okay, so the first step, the problem gives you that x of t is continuous. So you have to write that down since it's one of your conditions. That's condition number 1, continuity. And for condition number 2, you have x of 1 and x of 5, which the values it gives you are 3 and negative 2. Your k, 0, is between 3 and negative 2. So write that down as well. X of 1 is actually greater. X of 1 is greater than k, and k is greater than x of 5. I wrote it in the opposite way, since 1 is less than 5 here, but still you can see that k is between 0. K is between negative 2 and 3. That's your second condition. You've written these two down. Now I can say, yes, there must be a value r between 1 and 5 such that x of r equals 0. And that's how you solve intermediate value theorem problems.